Hello, my wonderful computer science students. Welcome to our next lesson in Unit 4 Data Collections on Data Sets. This is going to be Lesson 2 in Unit 4. If you're new here, I'm Goldie, and I'm here to make AP CSA easy for you to understand. Now, we are going to be going through talking about data sets. This unit is all about data collections and really, as programmers, how we collect the data and then process it and output it. So in the bigger picture, we're going to specifically talk about data sets and how we can use different data sets to answer questions that we might have. So as we're going through, first we're going to talk about what exactly data sets are, because as we're talking about different data sets and as we eventually get into programming with different data sets, it's always good to keep in mind the content as to what we're doing, right? So when you're thinking of, okay, how can I process this data set, it's good to think of examples of what data sets are. So with the formal definition, okay, data set, it's a collection of related data points that can be analyzed to find patterns, answer questions, or make decisions. And that's really what it's going to be for us. So each data point typically contains values. Different textbooks call them different things, fields, variables, but it's tied to a subject of some kind. Now, these data points can be, of course, there's qualitative, quantitative. You can get even further, discrete, continuous, right? There's many different types of data categories. We're not going to go into those necessarily. We're just going to look at the bigger picture of data sets. So some data sets that could be good examples for you to think about as you're working with different data might be grades. Grades are kind of the go-to for all of us in school. It's the data set that we probably use most often in school, right? So different grades from students in a school. Also that we encounter weather. Weather has so many data points. So think of like daily high temperatures or daily low temperatures. We could use those data sets. Purchases made at a store. Right? How much was purchased in terms of cost, or how many items were purchased in terms of quantity of items. There's a lot of data points that come up in everyday purchases, or even songs that you are playing, right? Songs in your playlist, how often you listen to them, etc. There's a lot of information being gathered just whether you're using Spotify or YouTube. Okay, so these are all examples of data sets, data we can gather and have on individuals. Okay, now what's the purpose of a data set? Because you've heard a lot about how we gather data, how companies gather data, people gather data, right? But what's the purpose? All data is collected with a goal in mind. Okay? Data is, I wouldn't say it's expensive to keep, but we keep a lot of data, right? And if we keep a lot of data, we want to have a purpose to collecting it and then keeping it. Okay, so what is the goal? What's the purpose of collecting a data set? We want to make sure that when we collect data, we use it for its intended purpose. If we use data that we have to answer a question it wasn't meant for, you may get misleading results, or you may get results that fit one agenda over another agenda in certain situations as well. So you have to keep in mind that when you collect the data, collect it with a purpose and then use it for that purpose, and don't apply it to situations that wasn't meant for. Okay, so for example, a good fit here. If we collect data on student test scores across multiple semesters, so test scores in our class across multiple semesters, even across multiple years, right? If I want to identify trends in performance, I look at those student test scores throughout the year and across multiple years. Is it a good fit? Yes, because I can look for patterns in scores, right? Do students do better or worse first semester versus second semester? How have students been doing since, let's say, online learning started or asynchronous learning started? So you want to look. I collect that data, test scores, with the purpose of looking for trends and looking for those patterns. An example of a bad fit, again, if I collect student test scores, but I want to identify who is most likely to arrive late to class. Now, do test scores accurately reflect who's going to arrive late to class? And we can make a joke about it, right? We could joke about certain people in class and their test scores and their tardiness, but in reality, it doesn't always apply to that. So we want to make sure that it's a good fit. Lateness is unrelated to test scores in the big scheme of things. Again, we can make a joke about it, but lateness is unrelated to test scores, okay? You can arrive late every day, but if you're prepared and ready for a test, you can still get good test scores, okay? Okay, so given a list of different data sets, match each to an appropriate question. So this was just something I came up with to help you start thinking about the data sets we collect and the questions we can use to answer it. On the AP exam, this is a new topic this year that they want covered in the objectives. So it's hard to say exactly what the questions are going to look like on the AP exam. The examples that they've given us so far really have are given students a data set, and you have to be able to say, okay, which questions can be answered using that data set? So that's kind of where this question comes in. If you want to pause the video and try it on your own, you are matching the question with the data set. So for number 1, for example, which day of the week is most profitable? Which of the data sets A through F would be able to answer that question? Which seems like it matches, right? Gym check-in logs, which day of the week is most profitable, those seem to mismatch. Again, like maybe you could align stuff, but the goal isn't for a maybe. You want to have a question in mind and then craft the data set that you need to answer that question. So that's why we start with the questions and then figure out what data set matches. So if you want to pause, try it, press play when you're ready to see these answers, okay? Number 1, which day of the week is most profitable? Sale numbers at a bakery. You're going to be looking at sales number at a bakery to answer that question. That would be a good data set for that question if you were running a bakery, okay? How does social media use impact mental health? Okay. This is another question. Again, which data set can be used to craft an answer to this? A survey on teen stress levels. Some of you might have been tempted to say C, app usage, but remember that doesn't give the full picture. That can give maybe a piece of a picture, but if we want to start answering the question with the full picture, we need to look at teen stress levels. What time of day do most people work out? Gym check-in logs are going to be good. Again, maybe streaming music plays count by genre. Okay, maybe streaming music can be affected by, what time of day do people work out, right? There's a loose connection there, but we always want to make sure that we have a data set that has a strong connection to the question we are trying to answer, okay? Which type of music is most popular? That's when we're looking at streaming music. Is there a pattern between absences and grades and math? That's when we'd look at school attendance records. And what time of day do people use their smartphone the most? The last one, app usage data collected by smartphones. Okay. Again, we want to have that data set match the question. We want that data set to answer the question it's intended for. Okay. Manipulating and analyzing data. Okay, so when you ask a computer to look at the data, they just don't look at it all at once like we might if we're given a sheet of paper with data. We see the big picture, but computers can't do that. When they have data, they do the following. First, they access it. So computers process one value at a time. Again, even if we as humans, we look at a table and we see the full table, computers don't see the full picture. They have to analyze one value at a time, or if you're looking at a table here soon, they're gonna have to look row by row. Okay, column by column. Once they look at each value, then they have to process. So that's when they use algorithms to transform the data in some way that makes sense to them, or to look at the data in some way that makes sense to them. And that's really what the rest of this unit after this lesson today is going to look at, is how we access the data in whatever form we have it, and then how we use algorithms to decide what to do with that data. Okay. And then filtering, they also filter data, narrow down results. For example, if we have student grades, again, looking at students who only scored above a 90% in some way. Computers are really good at filtering data and filtering data with a purpose in mind. Okay. So here's 4 examples that I have here looking at data sets. When we look at a topic, what question we can answer, what type of data we can collect to answer that question, what can we analyze with an algorithm, and then what decisions can be made. Again, this is just more, these are 4 examples that are just meant to help frame your mind into how we want to get data sets with a purpose, right? It's always with a purpose, because from here out, after this lesson, I'm going to give you data sets, right? Or you're going to find data sets, or I give them to you. You're going to use data sets in a purposeful way. So we got to start thinking about doing that. So let's say a school lunch, a hot topic right now, right? School lunch. Let's say we want to answer the question, what meals are most popular among students? What type of data can we collect to answer that question? We can collect cafeteria sale records. We can collect the meal types, what types of meals were sold, A choice versus B choice, etc., or student purchase logs even. We can collect different types of data to answer this question. Then what can we do to analyze this with an algorithm? Well, we can count the frequency of each meal purchased. We can find patterns over different days of the week. Maybe something's more popular on Monday versus Friday. We can use algorithms to help answer this question, right? What decisions can be made? Well, once we have the data, we can maybe adjust menu options if we want to make sure that the most popular meals are available to students, stock more of them to make sure we don't run out, and reduce waste. If there's something that's less popular, don't make as much of it. Okay, you see what I'm saying here? So all of this are things we got to keep in mind as we are looking at the data. We want to know what data can we collect, what algorithms can we use in terms of counting frequency, filtering data, sorting data, how can we process the data to help us make a decision. So here is another example. If we were in class, we would have more of a discussion of these. But since we're not in class here, I'm just going to kind of give you the answers that I have and that we've talked about in class previously, right? So question to answer for fitness tracking. Let's say if you have one of the rings, fitness rings or fitness watches. Let's say that one of the questions we want to use is what time of day do users exercise the most? We can collect timestamps from check-ins or fitness apps, activity logs. Again, if you think of like your Oura ring or something, right? We can check those. What can we analyze? We can analyze group activities by the time of day. Are there more group activities going on maybe at a gym? That time of day, what are peak activity periods, right? We can look for like mins and things. When you think of algorithms, you can think of like mins and maxes, modes, the most occurring. If you need to find averages, again, if you need to count something, all of these things are algorithms we can get and use on the data. And then what decisions we can make, okay? If we're at a gym, we can schedule more trainers, or classes during the busy hours, right? If you're a fitness app, what decisions can you be made? Well, you can make smarter recommendations for the users, right? So this would be in line with the topic of fitness tracking. Okay. Online shopping, which products, let's say you want an answer to the question, which products are frequently bought together, okay? If you're running a chain store, okay? We can collect transactional data, product IDs, shopping carts, orders. We can look at which items are commonly paired together. So this algorithm would be looking at pairs and how often items are paired up together. And then, of course, the ideal would be to suggest product bundles. Okay, if someone buys this, hey, we suggest this because people more frequently buy this, right? If you've ever been on the Amazon app and they say like frequently purchased together, this would be exactly what we're talking about here for online shopping to improve those recommendation systems. All right. Last one, environmental monitoring. Which neighborhoods have the highest levels of air pollution? If this was a question you wanted to investigate, what type of data could you collect on air pollution? There's air quality sensor data, location coordinates, and date timestamps. Now, again, like location coordinates, why would I just collect that? But the idea is that you have more data to collect to help you answer these questions. So you collect all of this data and then put it together to help analyze with an algorithm, which would be maybe average pollution readings by location, or you can visualize these patterns on a map, on a density chart for air pollution. Okay, so we can analyze all of those with an algorithm, and then maybe target environmental policies, install air filters, or even just awareness of air pollutants to the public. Okay, so all of these questions to answer, data we can collect, what algorithm can we use, and then what decisions can be made. Representing data, okay? So now that we have kind of the big picture of data collection, what can we use to represent data? Unorganized data is very hard to work with, as you'll see. But by picking the right representation, you can spot patterns and trends, make decisions, and explain results to others. Now, the ways which we represent data, there's so many ways we can, okay? You've seen so many ways. The first way that's kind of most common is with a table. It organizes raw data very clearly. For example, a list of student names and the test scores right next to them. We're going to work mostly with data in AP CSA. Starting with the next lesson, we're going to start working with one-way tables in the form of one-dimensional arrays. Then eventually we get into array lists, which are another form of one-dimensional tables, and then eventually we get into 2D arrays, which are going to be two-way tables. Okay, so we're going to represent data mostly with tables right now in AP CSA, but there's other representations you're going to see. There's, of course, bar charts that compare categories. There's line graphs, which show changes over time, and then scatter plots, which are going to show relationships. Now, these types of graphs we're not going to make in an AP CSA. We can make some very rudimentary forms of bar charts in terms of just displaying, not necessarily like an interactive bar chart that you might see online, but tables we're going to work with first, because mostly tables can be translated into all of these other visual forms of representation. Okay, but I want to do an example just for fun here, and just to show you the process of how we go about representing data. Okay, this is more something we would do in AP statistics, but I still love it. So if we were in class, I would ask you, of the choices given, which superpower would you most like to have? So I give you all of these options, and then we would write down what you guys decide. So of the options, there's flying, telepathy, x-ray vision, psychokinesis, time travel, invisibility, or superhuman strength. And you have to choose one of them. Okay, don't be someone who's like, oh, well, I have this offhand. No, these superpowers are your choices if you had to choose. Okay, so we'd write them out. Okay, and I would write out one by one everyone's answer. Okay. Now, if I write out everyone's one by one answer, that's going to, on the board, that's going to be very unorganized. So step one of any sort of data processing is going to be organizing the data, okay? Organizing it in a meaningful way. And one of the easiest ways to do that is with a table, okay? And that is something that we would be doing in class and programming our program to do, okay? So use the space below in your notes to create a table and organize the data. Here's an example of sample data that was collected in one of my classes. So here's the power listed. Okay, so here's I think there were 7 of them. Yeah, 7 powers. And then count represents how many students chose each of them. So 4 students wanted flying, 3 wanted telepathy, etc., etc. Okay. So if you want to pause and write that down as an example, since we're not in class right now. Okay. And then visualize the data. So we can make a bar chart and use it to answer questions. Okay. So we go from organizing data to now visualizing it. Okay. So for us, visualizing, we're very, for humans, we like looking at charts. It's just an easy way to visualize data. For the computer, you're going to want to organize it in a meaningful way. So in CSA, maybe that looks like organizing it with variables. Maybe it looks like organizing it with objects or with arrays of different kinds. So in the programming world, you have to choose the way that's going to best represent your data on your program or in your program, okay? And then after you organize your data in some way, then you want to start analyzing it and asking questions, okay? So first we're going to visualize this data. So if we're just drawing a graph, again, not something you usually do in CSA, but I want to show how you can use the data, visualize it, and then answer questions, because this process is really what we're going to be starting to do in lesson 3, is going through with this data. So a bar chart, pretty straightforward. Your bars go up to the number of students that there were. So for flying, we had 4 students choose flying. For telepathy, there were 3 students who chose telepathy, mind reading, okay? And then each of your bars are going to go up to the frequency from there, okay? So this is what it looks like when it's all said and done, okay? But organizing the data and then being able to visualize it. Now, visualizing for a computer, what we're going to see is that's going to be more in form of what we call traversing, right? Traversing means going through the data. So once we have it organized, whether that's in an array list, in a 2-dimensional array, we're going to organize the data into one of those data structures. And then from there, visualizing it for us humans is looking at a graph. But visualizing for a computer, you're going to want to traverse it, which means look through each data value. Okay? And then once you do that, then you want to answer questions. So for us, we can look at a graph and answer questions based on this graph. For a computer, when you traverse it, you want to start asking questions about each of the data values that it encounters. And you're going to be doing that with an algorithm. Okay? And we're going to have all of that good stuff coming up in the next couple lessons. Okay? For us, I just have 2 easy questions. What patterns do you see in the graph that you couldn't see in the raw data set? So think of raw data again when I just listed out the words on the board. Okay? Not necessarily the table, because the table is an organized piece of data. That's part of organizing your data. But what could we see in the graph that we couldn't see necessarily on the board? Well, what we saw in our example data, and this might vary depending on people from person to person. In our example data, many people chose time travel, flying, and superhuman strength. Those were the top 3. Now, all of those are very adrenaline-charged powers, okay? Unlike psychokinesis or invisibility. Psychokinesis would be like moving things with your mind around the room, right? Like moving a pencil around a room. And what we decided, this data tells us that we like more practical adrenaline charged superpowers, which means we think more practically, right? So time travel, that has a lot of practical implications. Flying makes it easy to travel, and then superhuman strength obviously has its uses as well. So these were kind of the answers, the fun answers we came up with when we analyzed that data. Okay, for us as programmers, step 1. Organize the data into a data structure. Step 2 is going to be to traverse that data. And then while we're traversing the data, step 3 is analyzing it in some way. Okay, gathering, using an algorithm to gather sometimes statistics, but sometimes just insights to help us answer that question, which is the question that led us to gathering the data in the first place. Okay. So algorithmic approaches, okay? So basic data processing algorithm has 3 parts, okay? Input, gather the data, okay? Take a survey, track data that's available, etc., etc. So many ways to get the data. Processing involves cleaning, sorting, and analyzing it, okay? So this would be, for example, removing duplicates, finding averages. You would be looking at the data to process it in some meaningful way. And then output. Show the results clearly. So whether it's going to be as a graph or organized in some report is usually how we're going to see in APCSA. Okay. So for example, an example of this process would be like Netflix collects your watch history, which would be its input, analyzes trends in what you are watching, and then recommends shows as the output. Okay. So basic input, process, output is the algorithmic approach to looking at these data sets. Okay. Now, if we're in class, we would finish this set of notes with a practice problem where, again, we would have a question we would think about what data set we could use to help us answer that question. We would think about the algorithms that could be used on the data sets to help us answer that question. And then which decisions could we display to the user and have it be in a meaningful way. So those would be step 1, 2, and 3 for designing a fitness app to recommend daily step goals for your user, a user who's using your app. So if we're in class, we would do this. We're not in class, so I invite you just to finish off this section of notes here as a little thought bubble and to help you kind of understand this process. Because starting in lesson 3, when we first start learning about one-dimensional arrays, we're going to be starting this process of input, process, and then output. And that brings us to the end of the notes for today. Thank you guys so much for following along. I appreciate it. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more great AP CSA content. And until then, I will see you in the next video, lesson 3, talking about one-dimensional arrays. Thank you guys so much. See you then.